Hello guys, welcome to our next lesson. What we are learning today is factorizing polynomials. So let's get straight into it. First example, let's show that x minus 2 is a factor of px polynomial of all of this. Now, we've done this before previously. To show that it's a factor, that means when you are dividing it, you should have a remainder of 0. That means your remainder theorem, if you apply your remainder theorem, you should get 0, okay? Now, when you're applying your remainder theorem, your x is going to be 2 because 2 minus 2 is 0, yeah? So we're going to sub x as 2 into here, so all your x's becomes 2. So P2 equals 2. Make sure you put brackets when you are substituting. 7 minus 2 squared minus 3 times 2 plus 18. Now, if you put that all into your calculator, you should end up with 0, which means there is no remainders. That means x minus 2 is a factor. So you say, therefore, x minus 2 is a factor. However, the question doesn't stop there. If it says, hence, express px as a product of its factors. Now, when they say products of its factors, what does that mean? Product technically means times, and factors means the little numbers that can be divided into that product in that polynomial. So for example, we know for number 12 we can have factors of 2 and 6 because if you times it, the product of 2 and 6 gives you 12. Or we can have 2 times 3 times 2, yeah? So these are called product of its factors. Now, how do we know 2 and 3 or 2 and 6 are factors of 12? So let's say we have 12 equals 2. We know 2 is a factor times something. Another factor gives you 12. To find that box, it's pretty easy. You would naturally do 12 divided by 2, which gives you 6. So same concept over here. We know x minus 2 is a factor of this polynomial. So I'm going to say that px, which is this whole polynomial here, has this as a factor, but we want to find the other factor. So naturally, we would divide. So polynomial divided by that should give you its other factor. However, division for polynomials isn't as simple as 12 divided by 2. We have to do long division. So we draw our long division sign out. Let's write your polynomial in. Okay, so first thing before you're performing your long division, you want to check whether the powers are all there and descending. So 3, 2, 1. Okay, we're all good to go. Let's multiply. So 2x, so something times x has to give you 2x cubed. So 2x squared times x gives you 2x cubed. 2x squared times minus 2 is minus 4x squared. To find the remainder, you would subtract it. That cancels. So we have minus 7x squared minus 4x squared, which gives you minus 3x squared. Okay, we're going to bring down the next one, the next term, it becomes minus 3x. So something times x has to give you minus 3x squared. So we know minus 3x times x gives you minus 3x squared. Minus 3x times minus 2 is positive 6x. You subtract it to find the remainder. So we have minus 3 minus positive 6, which gives you minus 9x. Now you want to bring down the next term, 18. So we have, let's say, something times x has to give you minus 9. So we know minus 9 times x gives you minus 9x. Minus 9 times minus 2 gives you positive 18. Now if you subtract this, you have a remainder of 0. So therefore, your polynomial is x minus 2, because that's a factor already, times this whole thing here. So times 2x squared minus 3x minus 9. Okay? However, this whole thing here, right, we can further factorize this quadratic to make sure it's a product of its factors. See how 6 here, you can further factorize it down to 3 and 2. Okay, break it down to 3 and 2. We're going to do the same thing. So let's say, I'm going to paste it here. There's two ways that we can factorize this one here. I personally like to do the cross method. So to do the cross method, what two terms multiply together to give you 2x squared? We know it's 2x and x. Cross method gives you a cross. What two numbers times together to give you 9, which is 3 and 3. And then you go down the chain. So 2x times 3 gives you 6x. Then same thing, x times 3 gives you 3x. And your ultimate goal you want to have is minus 3x. So we can have minus 6x plus 3 gives you minus 3x. We're going to transfer this into here. So your first bracket is going to be 2x plus 3. The minus sign I'm going to transfer into here. So therefore, when you factorize that, these would be your two brackets. Now, if you don't know how to do this and you prefer the PSF method, okay, so the product is basically the product of the last two numbers at the end. So 2 times 9 is 18. The sum is the one in the middle, minus 3. So you got to think of the factors that goes into 18. So 6 times 3 gives you 18. Yeah, but you want to have a sum of minus 3. So we can have minus 6 plus 3, which gives you minus 3. So I'm going to rewrite this now. This here, if I rewrite it, we can have 2x squared minus 9 on each end. Positive minus 3x, we're going to change it using these terms here. So minus 6x plus 3x, which gives you minus 3x. Then you can start factorizing. So split them into two groups. The first one has a common of 2x. So you have left x minus 3. The second group here, you can factorize number 3 out. So you can factorize positive 3. When you take out 3, you get x minus 3. Looking at both of these terms, we see that x minus 3 is the same in both of them. So we can factorize that out. If I take out x minus 3 from this term here, I'm left with 2x. So I have left 2x. And then in this term here, I have left positive 3, which turns out to be the same. So if I rewrite this, therefore px equals to x minus 2, okay, because we're looking back at this one here. And then if you factorize the other one, which is 2x plus 3, x minus 3. And that is how you completely factorize a polynomial. Thank you, guys.